So far we have done stuff with ionic compounds. And an ionic compound is always going to be a metal versus a non-metal. So anytime you see a compound that's a metal and a non-metal, that is ionic. Okay? So whenever we have like calcium fluoride, calcium is a 2+, fluorine is a -1, we end up with CaF2. This is an ionic compound because it's a metal compared to a non-metal. So let me show you what the other thing is that is not ionic. The other thing is covalent. Covalent means that you are sharing electrons. So this is sharing, I should say, valence electrons. So a good example is water. Water is H2O. Hydrogen has 1 valence electron, and oxygen has 6. 1, 2, 3, 4, 5, 6. So these 2 electrons would get, let me pick a better color here. These 2 electrons would get shared, and you would end up with something that looks like that. And then you have your extra valence electrons, where the line represents the bond, the shared bond between those. So these are only bonds between non-metals. So all of our covalent compounds are going to involve non-metals. And let me show you how to write the formulas and do the names. It's a whole lot easier than the ionic compounds. I said that they are between non-metals, so I'm going to just pick some non-metals. Let's do phosphorus and oxygen. Okay, so if my covalent compound is made of phosphorus and oxygen, then, and I want to name this, well, first of all, you can't figure out what the subscripts are just based on the elements. So what I would do is I'm going to give you a formula, and you're going to come up with a name or vice versa. So in this formula, I'm going to say P3O2. So the basics are pretty simple. We write the name of the first element, and I'm going to leave some space out front. You're going to see why. So that is phosphorus. And then the next element, the oxygen, we're going to do the root word. I'm going to leave a space out front, and we add "ide." Now the space out front is very different than the ionic compounds. There's nothing in an ionic compound that tells you how many atoms, but there is for covalent. We're going to put triphosphorus dioxide. So triphosphorus dioxide literally tells you exactly how many atoms are in there. It's kind of cool. The prefixes are on a worksheet in OneNote, but 1 is mono, 2 is di, 3 is tri, and so on. Okay, you have to memorize all the way up to 10. So if I do, let me give you another one, CH4, this is methane or cow farts. You would think that you have to write monocarbon, and the number 4, the 4th prefix is tetra, and then tetrahydride. Good thinking, but you never ever start with mono. So if I want to write monocarbon tetrahydride, the last one ends in ide, I have to remember, don't ever start with mono. The first one cannot have mono. The second one can, but not the first one. Never start with mono. It can lead to kissing. Okay, so let's do, you've seen this one before. CO, capital C, capital O, is carbon, because we leave off the mono, and it is monoxide. Okay, don't write monooxide because then it's just monoxide. Okay, so that's how you write the names of these. And then writing the formulas is just as easy. I might have dinitrogen monoxide. The prefixes tell me exactly how many are in each. This one is nitrogen, this one's oxygen. The dinitrogen means 2 nitrogens and 1 oxygen. So I don't write that 1, I just leave it. Okay. We could do, let's see, tetrasulfide trioxide. So my prefixes are tetra and tri, and my roots are sulfur. Oops, okay, made a mistake. It would be tetrasulfur. So it'd be tetrasulfur, not tetrasulfide. The "ide" is only at the end there. So this is sulfur and oxygen. Tetra means 4, so 4 sulfurs. Trioxide, the tri means 3. Okay. I'm really not going to get into much more of that because that's really truly all it is. The covalents are pretty easy. On the test or quiz, I will give you a formula and you have to name it, and then you have to recognize, is it ionic or is it covalent? If it is metal to metal to a non-metal, okay. I wrote non-mental. I must be having a Freudian slip. I'm going to start over. Non-metal to non-metal. Oh, I meant to do the metal to non-metal. Non-metal to non-metal is covalent. If it is metal to non-metal, it is ionic. Okay? And again, how do you know that it's metal to non-metal? You know, which one is which? That's actually fairly easy just by looking at your periodic table. So all of these, let's see. Oops. All of the ones to the left of the stair step are metals, and the ones to the right are nonmetals. So these are all metals, and these are all non-metals. Okay, that's it. Go work on the worksheet I put in OneNote.